Okay, students, then we'll solve the problems. Okay, classroom workbook. PCM will have a separate topic in our classroom workbook. Pulse code modulation, separate topic. There now we'll start baseband data transmission or a PCM. Okay. Now this is question number 1. A signal whose amplitude is varies from a signal whose amplitude is varies from 0 to 10 volts is band limited to 10 kHz and transmitted through a channel using 4-bit PCM. The sampling rate is 50% higher than the Nyquist rate. The sampling rate is 50% higher than means 1.5 times the Nyquist rate. 50% higher than the Nyquist rate. Then he is asking determine all the parameters related to PCM. Now see here. Now number of quantization levels which is equal to 2 power n, which is equal to 2 power 4, which is equal to 16. Dynamic range which is equal to V maximum minus V minimum, which is equal to 10 minus 0, which is equal to 10, and the step size which is equal to dynamic range by L, which is equal to 10 by 16, 5 by 4. Sorry, 5 by 8. And the sampling rate. Now first we will find the Nyquist rate. The minimum sampling rate is called as Nyquist rate, but each signal, the signal is band limited to 10 kHz. 2 into 10 kilo, which is equal to 20 kilo samples per second is the Nyquist rate. Now the sampling rate, which is equal to 1.5 times the Nyquist rate, which is equal to 1.5 times of Nyquist rate, which is equal to 20 kilo. Now which is nothing but 30 kilo samples per second is the sampling rate. Okay. Now this is the sampling rate. Now what is the bit rate? Bit rate RB, which is equal to 1 by Ts into n. 1 by Ts is 30 kilo into n. Number of bits per sample is 4, which is equal to 120 kilo bits per second. And the bit duration TB, which is equal to 1 by RB, which is equal to 1 by 120 milliseconds. And the maximum bandwidth, which is equal to RB, which is equal to 120 kilohertz. Right? Now the question number 2. Now your classroom workbook. Question number 2. Same question, but what is given here is a message signal m of t, which is equal to 10 cos 2 pi into 10 power 3 into t is sampled and transmitted through a channel using 8-bit PCM. And the sampling rate is twice the Nyquist rate. and the sampling rate is twice the Nyquist rate. Calculate all the parameters. Okay. Now this is the message signal. What is the message signal? M of t, which is equal to am cos 2 pi fm into t, right? So now here the frequency fm, which is equal to 1 kilohertz. Now number of quantization levels 2 power 8, because n is 8, 256. Now dynamic range is V peak to peak. V peak is 10, V minimum is minus 10. So V peak to peak is 20 volts. Now step size is the dynamic range by L. L is nothing but 256. Now Nyquist rate is twice the 2 times of the highest frequency present in the message signal. The highest frequency present in the message signal is only 1 kilo. Therefore, this is 2 kilo samples per second. And the sampling rate is twice the Nyquist rate, which is equal to 2 times of 2 kilo, which is equal to 4 kilo samples per second. Bit rate is sampling rate multiplied with n number of bits per sample is 8, therefore 32 kilo bits per second, and bit duration is 1 by 32 millisecond. Maximum bandwidth is 32 kilohertz. This is question number 2. Okay, now the question number 2 is the question number 3. Your classroom workbook. Than the Nyquist rate, 20% higher than the Nyquist rate. Now he is not asking all these things. He is just asking bit rate and bandwidth. That's it. He is just asking only these two, bit rate and bandwidth. Okay, these two he is asking. So if you want to find all these things, now first we require to find the Nyquist rate. Okay, now the Nyquist rate means I want a Nyquist rate. If you want to find, first we need the message signal frequency. but in the question he is not mentioning the message signal frequency. But now you know that what is a video signal. Each video signal, if it is not given, you know that the video signal is band limited to 4.5 megahertz. Therefore, the Nyquist rate, which is equal to 2 omega, which is equal to 2 into 4.5 mega. Therefore, the Nyquist rate, which is equal to 9 mega samples per second. Now, the sampling rate is 20% higher than the Nyquist rate, which is equal to 1.2 times of 20% higher than the Nyquist rate is 9 mega, which is equal to 10.8 mega samples per second. Now, what is asking bitrate and bandwidth. So now first you want to find, now the sampling rate is that, and bitrate. What is bitrate? The bitrate RB, which is equal to the bitrate RB, which is equal to 1 by TS into N, which is equal to 10.8 mega into N. N is not given in the question. N is not mentioning in the question, right? But now in the question he is mentioned a video signal is transmitted through a channel using PCM and the sampling rate is 20% higher than that of Nyquist rate. Determine bit rate and bandwidth if the number of quantization levels used are 1024. What is given? The number of quantization levels used are 1024. You know that 2 power n, which is equal to L, 2 power n, which is equal to L is 1024, which is equal to 2 power n. 1024 we can write it as 2 power 10. Therefore, n which is equal to 10. Therefore, this is nothing but 10-bit PCM system now. Therefore, the bandwidth which is equal to bitrate 1 by TS into n is 10, which is equal to 108 megabits per second, and a maximum bandwidth which is equal to bitrate RB, which is equal to 108 megahertz. Sometimes in the question he is not mentioning the frequency. He is mentioning audio signal, video signal, voice signal. You know the boundaries of voice, audio and video. Then you can take that highest frequency among those particular band. Now question number 4. A sinusoidal signal is band limited to 5 kHz. A sinusoidal signal means a peak amplitude of AM, minimum amplitude of minus AM, frequency of FM in general, because a sinusoidal signal, which is nothing but a message signal which is input to the any system. Now a sinusoidal signal is band limited to 5 kHz and transmitted through a channel using PCM. A sinusoidal signal is band limited to 5 kHz and transmitted through a channel using PCM. The maximum quantization error is, what is given? The maximum quantization error is 0.1% of 0.1% of the peak signal amplitude. 0.1% of the peak signal amplitude. The maximum quantization error is 0.1% of the peak signal amplitude. Determine the bitrate and bandwidth. Now determine the bitrate and bandwidth. What is the bitrate and bandwidth formulas, you tell me? Bitrate is 1 by Ts into N. We required N and 1 by Ts. What is the bandwidth? The bandwidth which is equal to bitrate Rb, which is equal to 1 by Ts into N hertz. So we required these two parameters. So now first we want to find N and 1 by Ts. But what is given? A sinusoidal signal is band limited to, he is given, a sinusoidal signal is band limited to 5 kHz and transmitted through a channel using PCM. If nothing is given, the signal is done at the minimum rate, which is called as Nyquist rate, which is equal to 2 into 5 kilo, which is equal to 10 kilo samples per second. The sampling rate, which is equal to 1 by Ts, which is equal to Nyquist rate, which is equal to 10 kilo samples per second. This is the sampling rate, which is nothing but the Nyquist rate. So now the bitrate, which is equal to the maximum quantization error, which is equal to 0.1% of the peak signal amplitude, is AM, right? Now this is the maximum quantization error which is given in the question itself. Now what is the dynamic range here? This is the dynamic range. The dynamic range, which is nothing but V peak to peak. What is V peak to peak? 2 AM. What is the step size? The step size, which is nothing but dynamic range by L. Dynamic range, which is equal to 2 AM by L. What is the maximum quantization error? The maximum quantization error, which is nothing but step size. The maximum quantization error, which is nothing but step size by 2, which is equal to 2 AM by L into 2, which is equal to AM by L. This is the maximum quantization error. The maximum quantization error, which is equal to AM by L. Now the maximum quantization error is AM by L, which is equal to 0.1% of peak signal amplitude. AM cancel. Now L, which is equal to 1000. 100 by 0.1. Okay. But you know that now 2 power n must be greater than or equal to L. Am I not? 2 power n must be greater than or equal to n, and this n is, what is n definition? You know that n definition is next immediate integer. Next immediate integer when compare with the number of quantization levels. Next, immediate integer when compared with the number of quantization levels. Therefore, 2 power n, which is greater than or equal to 1000, then the next immediate integer when compared with the number of quantization levels are, now 2 power 9 is not satisfied. The next immediate integer is 2 power 10 is greater than 1000. Next immediate integer. Therefore, n, which is equal to 10. Therefore, now the sampling rate, which is 10 kilo into n is 10, which is equal to 100 kilo bits per second, now which is equal to 100 kilohertz. This is bitrate and bandwidth. Now question number 5. A message signal m of t, which is equal to 4 cos 2 pi into 10 power 4 into t is transmitted through a channel using 2-bit PCM. The sampling rate is twice the Nyquist rate. Calculate all the parameters of PCM if the sample values are. The question is given sample values. Some of the sample values are given as, what are the sample values which is given? 3.9, 2.1, 1, minus 0.4, minus 3.1, minus 3.6. These are the sample values. Now determine the quantizer output. Quantizer output means quantized sample value. So if you want to find the quantizer sample value, now we must and should design a quantizer. Now which bit PCM system? Transmitted through a channel using 2-bit PCM system. 2-bit PCM system means how many number of quantization levels? 2 power n, which is equal to 4. What is the step size? Dynamic range by L. What is the dynamic range? V peak to peak. 8 by L is 4, which is equal to 2 volts. Then you design a quantizer first. Now let us see here. Now the signal whose amplitude is varies from minus 4 volt to plus 4 volts. Now this is minus 4 volt to plus 4 volts. This is 0 volts. Now this is a signal amplitudes. This is plus 2 and this is minus 2. Signal voltage level. But what is the original sample values? You can easily identify 3.9, 2.1, 1, minus 0.4, minus 3.1, minus 3.6. Okay. Now the number of quantization levels are 4. So I can split these two quantization levels. This is the first quantization level. This is the second quantization level. This is the third, because some quantizations from the negative side, some are from the positive side, but total is 4 quantization levels. And the successive difference between each and every quantization level must and should be 2. 3 minus 1, 2. 1 minus of minus 1, 2. Minus 1 minus of minus 3, 3. These are the quantization levels. And each quantization level is encoded into 2 bits. Now, what is the quantizer output? Now, the original sample values. 3.9 is round off to 3. 2.1 is round off to 3. 1 is round off to 1. Minus 0.4 is round off to minus 1. Minus 3. Minus 3. And what is asking? Quantization error. Quantization error. What is the quantization error? Quantization error, which is nothing but quantized sample values minus original sample value, I am saying. Okay. Deviation error. Now, minus 0.9, 0.9, 0, minus 0.6, plus 0.1, plus 0.6. These are the quantization error for each samples. What is asking? Quantization error for each sample and output of the encoder. Encoder output. Each quantized sample is encoded into 2 bits, 2 bits, 2 bits, 2 bits, 2 bits, 2 bits. Now these are the designing of a quantizer encoder output. This is encoder output. Sample value, quantized sample value, quantization error and encoder output. Okay, then what is the quantization error? The quantization error boundary is minus delta by 2 to plus delta by 2. Therefore, minus 1 volt less than or equal to quantization error and less than or equal to plus 1 volt. This is the quantization error. Now, what should be the quantization error? This is the acceptable quantization error from minus 1 to plus 1. All are within minus 1 to plus 1, therefore it will be correct. Now, this is the best way to design a quantizer. Okay, the question itself, what is quantization error, what is encoder output, now what is the quantizer sample value. Now, he is asking to design a quantizer. Okay, now this is the question number 5 is this. Now question number 6. Consider a system as shown in the figure. Consider a system as shown in the figure below. Now these are the options. Question is, now by considering the system as shown in the figure, now this is input quantizer V1 added with some k value and again applied to the same quantizer, and output is V2. Now the question you remember, the question is determine minimum value of k such that V1 and V2 are differ. Options are this. Read the question once again. Determine the minimum value of k such that the V1 and V2 should be differ, not same, should be differ. Okay. Such that what should be the added value of k, and options are this. Okay. Clear or not? Question is clear. So for better understanding, I just give one small problem here. Same problem, whatever we covered. Now this is 2 volts, 4 volts, 6 volts signal strength. Now this is the quantization level, 3 volts. This is the quantization level. Now this is the quantization level, right? Now we'll see. Now let us take some value. Now let us take some input of 2.2 volts or something, whatever. Okay. Now this is input. How much? 2.2 volts. Okay. Now step size is 2 and everything. Okay. For example, now 2.2 volts. Then this is going for the quantization process, and this is the quantization. Okay. Take some example, whatever we covered. So where is 2.2? This is 2.2. Whose nearest quantization level is nothing but 3, which is the V1. Okay. What is V1? V1 is 3 volts. Okay. Now V1 is 3. Now what is asking? Now this is V1 plus K. This is V1 plus K, which is input to another quantizer, right? So V1 plus K, which is input to the another quantizer. So now what is the value of K? Okay. How much value of K is added? Okay. So now we can write like this. This is V1 plus K. Now here I just mention only K, the K value. Now let us take this is 0.5, k is some 0.5. So what is V1 plus k? V1 plus k is 3 plus 0.5, 3.5. Now this is applied to the quantizer. If this is applied to the quantizer, same quantizer, where is 3.5? Same quantizer. This is the same quantization level. 3.5 is here somewhere. But even if it is a 3.5, the output is same. V2 is, what is V2? Is same 3. But what is V1? 3. What is V2? 3. Both are same. But what is the question asking? Determine minimum value of k such that V1 and V2 are differ. So this is not the minimum value of k. Then I can take another thing. Same 2.2 volts. Now the answer is 3. Now I just take k value as 0.9. So now this is 3.9. Where is 3.9? Again 3.9 is here. If it is a 3.9, again this is round off to the quantization level 3. Again V2 is 3, V1 is 3, both are same. I want differ value. So now can I write like this? Now 2.2, again 3. Now this is 1 point something, 1.01 or something. Okay. So which is nothing but 3 plus 1, 4.01, exceeding 4. Where is that? Now this is a 4.0. Now it is crossing 4. When it is crossing 4, then whose nearest quantization level is 5. Now V2 is 5, V1 is 5. Now both are differ is correct. But what is the minimum value of k? What is the minimum value of k? Now if you observe here, this is the minimum, this is the value of k. But what is the value of k? But in options there is no 0.5, there is no 0.1, 0.3. All are in terms of delta. Am I not? Now under this situation, how much step size I am taking? Under this situation, step size is 2 volts. Am I not? Now in this situation, step size is 2 volts. Now if you observe here, this is 0.5 means this is less than delta by 2. Is it right or not? Less than 1 volt. This is also less than 1 volt, less than delta by 2, less than 1 volt, less than 1 volt. But now this is, see here, this is nothing but greater than delta by 2, means 1 volt, greater than 1 volt. But what he is asking, minimum value of k. What is the minimum value? Greater than or equal to. So the minimum value of k is the minimum value of k, which is equal to delta by 2. Which option? C. This is GATE 2006 2 marks question. This one, question number 6. All questions whatever we solved in the class are all our previous GATE examination questions. Before we start the question number 7, we just see one small concept here. Now this is the message signal. Peak amplitude is AM, minimum amplitude is minus A. This is the message signal. Now this is undergoes the process of sampling, quantization and encoding. And this is a sequence of ones and zeros. Okay. Now the output of the quantizer is the quantization error, which is nothing but quantized sample value minus the original sample value. Okay. Now almost all the samples are undergoes the process of quantization. So definitely all samples are having some error. This is the quantization error. Now where there is a signal, then definitely there is an effect of noise. Therefore there is a signal here, there is a sample, there is a noise, there is a sample, there is error. Therefore this we call it as quantization noise. This error is also called as quantization noise error. Quantization noise. This error is nothing but a quantization noise error. Now this is the quantization error, which is equal to quantized sample value minus original sample value. This quantization error is nothing but quantization noise error. So, or we call it as a quantization noise. Okay. So now this quantization noise power, the quantization error is always depends upon the step size. This quantization noise power, which is nothing but delta square by 12. Okay. We will see the derivative part of this also the next sessions. Now this is the quantization noise power. Okay. Now what is the signal power? This is a noise power. Where is the signal power? This is the signal, continuous signal, analog signal, peak amplitude divided by root 2 is RMS value. VRMS square by R is signal power. So which is nothing but AM square by 2R, which is equal to R equal to 1 ohm. So AM square by 2 is a signal power. Now this is the signal power, this is the noise power. Now what is the signal to noise ratio? The signal to quantization noise ratio, which is nothing but signal power is AM square by 2 and noise power is 12 by delta square. Okay. So 6 into AM square by delta square. But what is delta? The delta, which is nothing but dynamic range by L. What is the dynamic range? 2 AM by L. This is the dynamic range. The dynamic range, which is equal to 2 AM by L. Now which is nothing but 6 AM square by delta is 4 AM square by L square. AM square cancel, 3 by 2 into L square. This is the signal to quantization noise ratio of a PCM system, which is equal to 3 by 2 into L square. L equal to 2 power n, 3 by 2, which is equal to 2 power 2n. Clear or not? Now L square, L equal to 2 power n, which is equal to 2 power 2n. Now this is the signal to quantization noise ratio of a PCM system. Now if you want a signal to quantization noise ratio in terms of dB, now this is the signal to quantization noise ratio. Now first you note on this, then after that we'll see. Now signal to quantization noise ratio in terms of dB, which is equal to 10 log 3 by 2 into 2 power 2n, which is equal to 10 log 1.5 base 10, 10 into 2 power n into log 2 base 10. Therefore, the signal to quantization noise ratio in terms of dB, which is nothing but 1.8 plus 6n. This is the signal to quantization noise ratio in terms of dB.